All right, in this next video here, we're going to continue our look at changing base and solving problems involving changing the base. So in lesson 12, we justified a number of properties of base 10 logarithms, right? That was the previous video, previous lesson, I should say, that we talked about in our previous video, the previous lesson. So now we're going to look at these properties for any base b here, okay? So again, it's going to be the same kind of properties, right? If I rewrite this in exponential form, we get b to the 0 equals 1, which of course is true as long as b is greater than 0, right? If b is 0, because 0 to the 0 does not equal 1, so, or it's indeterminate. But this is okay as long as b is greater than 0. So you can just see right there. Okay, again, rewrite this one in exponential form too. B to the 1 equals b, right? Which, of course, that's true, right? So that means this is true too, right? Here I said that was true. I'm here for letter C. Okay, again, we can use our properties of logarithms, bring that r out front there. So we'll have r times log base b of b, right? And we already established here that log base b of b is 1, so we can just use that property to say this is r times 1 or just r. So check, that's right there. Okay. Here, again, b to the log base b of x equals x, so to do this one, we can do log base b of b to the log base b of x, and we'll do log base b of the right-hand side too. Okay. So using our properties here, we can bring this log base b of x out front, because that's the exponent there. Okay, log base b of b we already said was 1, so this is just going to be log base b of x times 1 equals log base b of x. So check, they're the same, so check that's true. Okay, similar situation here, we'll do b to the left-hand side and b to the right-hand side. So the left-hand side will be, the entire left-hand side is the exponent of b, and here the entire right-hand side is the exponent of b, which as a result then, again, b to the log b, we know that's going to cancel, so we'll have just xy for the left. Actually, I'll do it down here. Xy for the left-hand side, and then here it'll be b to the log b of x plus log b of y. Okay, that addition there, right? When you add, remember we can use our logarithm property or exponent properties, right? If you have x to the 2 times x to the 3, that's equal to x to the 2 plus 3, right? Now, normally we go from here to here, right, to simplify, but in this case, we have addition, like this, and we're going to break it up into a product of two things. So it'll be xy equals b log base b of x times b log base b of y. And again, both of those can now cancel, and we'll have xy equals xy. Check, that is correct, right? So check that is accurate as well. Okay. Same situation here, we'll do b to the left-hand side, b to the right-hand side, which would make this then, those will cancel, we'll have x to the r, and this one's b to the r times log base b of x, which again, you know, we can rearrange these here and say this is the same thing as saying b to the log base b of x times r, or in other words, to the r like that. These will exactly cancel, so we'll have x to the r equals x to the r, because again, this just becomes an x, right? Because the log base b and the b cancel and leave us with just the x. Okay, so check that's right, so check that's right. Okay. And then here for g, all right. Well, again, we see that division, which we know we can rewrite as log base b of 1 minus log. Oh, actually, I guess we haven't proved that yet because we're going to prove it down here, so never mind. We can write this log base b of x to the negative 1, which we can bring that exponent out front using properties of logarithms. And voila. Check they're the same, so check these are the same too. Excuse me. Okay. And then finally h here, okay, division, right? So again, same thing, b to the left-hand side, b to the right-hand side. Those are going to cancel, we'll have x over y. These right here, we can rewrite this as plus negative, like that. So we'll have b to the log base b of x plus negative log base b of y. Okay. Again, since we have addition here, we can break that up into two things. So it's going to be really b log base b of x times b to the negative log base b of y. So we have x over y equals, those cancel, we have x, and then actually let's bring that negative up into the exponent here, and we'll make it y to the negative 1. Okay, and so then those we cancel and have times y to the negative 1, which then is really x over y. So check that's right, so check that's right too. Okay, we'll stop there, and we'll then use some of these properties here for the ln, or natural logarithm, in the next video.